Hello, my name is Aaron Hope, and today we'll be discussing some applications of MathCAD's dimensional analysis feature. Given here is the setup for an osmotic pressure problem. Given masses of both solute and solvent, we want to determine the osmotic pressure of the resulting solution. To do this, we will use our osmotic pressure equation seen here. As you can see at this point, we don't have the mole fraction defined, and our molar volume is given in units of volume per unit mass instead of per unit mole. These are issues that we will have to remedy in order to solve this problem. To consider MathCAD's unit analysis feature, we will first consider the gas constant here. You'll notice here I have it given in units of liter atmosphere per mole Kelvin. However, it may be more convenient to define this unit in terms of joules per mole Kelvin. To do this, I simply select the units given, highlight them, replace them with joule per mole Kelvin, and press enter. You will notice that the gas constant is then expressed in terms of the units joule per mole Kelvin. This is an incredibly powerful tool for engineering students as it allows us to quickly and efficiently convert between different unit systems. However, this system is not without its drawbacks. Some variables are defined in unexpected ways. Consider this definition here for a given mass of salt. When I try to express this mass of salt, I get a unit of meters per second squared. This seems odd because we have defined mass of salt as 0.5 grams. However, MathCAD defines certain letters as universal constants. In this case, the letter G is defined as the acceleration due to gravity, seen here. You will notice that in the problem statement, all masses are given with the suffix gm to indicate gram instead of g, which in this program indicates acceleration due to gravity. Any user operating with MathCAD must be careful not to define units using universal constants, and there are many. Now, let's try and solve the problem that we have been given. To do so, first we must find the mole fraction of sucrose, and then we must find the molar volume of water. To do this, we see that the calculations for moles of sucrose and mole of water are carried out, and conveniently, units are carried through the calculations. To find the mole fraction of sucrose, we then divide the moles of sucrose by total moles, and we receive a unitless number as we would expect. Furthermore, when we find the molar volume of water, we find that the units work out well without us having to convert between them. We see that VH2O, which was defined in terms of meter cubed per kilogram, is multiplied by molecular weight of water, which was defined in terms of gram per mole. This would usually be a difficult conversion, but when we have MathCAD take care of some of the intermediate steps for us, it increases our efficiency as it reduces our time. And you can see here that we find the molar volume of water in terms of meters cubed per mole, as we would expect. Finally, to solve for osmotic pressure, we can simply move our osmotic pressure equation down below, where we had previously defined our necessary variables, and then we simply write out our osmotic pressure symbol and press equals, and we see here that we can solve for the number we have been looking for. This has been Dimensional Analysis with MathCAD. I'd like to thank you for listening. Have a good rest of your day.